Like every global landscape in the world today, regions of permafrost are undergoing an aggressive transition in the frozen tundra. The cryosphere ecosystem was once a source of stability for the Arctic climate. Incredibly strong, adapted, and resilient, permafrost helped form the northern hemisphere that we have today. As climate changes, it is unlikely that permafrost will still exist a couple of decades from right now. Throughout Earth's historically changing climate and landscape, sporadic warming seasons led to drips of meltwater meandering into lower permafrost layers where sediment, soil, and the crystalline structure of ice had pockets just large enough for the undetectable trickle, and over decades, the veins grew in volume. Beginning like small capillaries amongst the permafrost, the once finely woven striations continued to expand as freezing and thawing events continued to change the volume that they occupy. Today, the petite channels of centuries ago have more parallels to the permafrost hemorrhaging meltwater vertically to layers below the surface. As the warm water molecules continue to permeate lower levels in the permafrost, a centuries-old interaction threatens to destabilize deeper layers of permafrost today. As the positive climate feedback has the scientific community consumed by worst-case scenarios, the meltwater channels continue to grow in volume. Adjacent molecules that come into contact with the warm water gain in temperature, which under that type of pressure and weight at that depth can be very dangerous. Instead of the lateral stratification of the upper layers of the permafrost, the small water channels do not follow any annual freezing or thawing pattern. Dense and stable permafrost layers are now exposed to a climate feedback that can cause major degradation and advanced and increased tunnels and pockets from the traveling meltwater are beginning to form. Without threatening more structural damage to the deeply frozen layers of permafrost, it is impossible to understand the immensity of what may be going on underneath the subsurface of the surface permafrost. How expansive is this underground system, and at what celerity is this invisible nexus evolving? Meanwhile, in areas where answers are more readily observable, thermal erosion tells an even more ominous tale of climate-related tragedy. The degradation of the Arctic is a constant reminder that moving forward, the trajectory of these potentially catastrophic events is the most uncertain time in the Earth's climate history, fated by one single species. Knowing humans manifested this destiny after decades of recklessness still hurts like the betrayal of a dear friend. If we could ask, I'm sure the Earth would admit to feeling betrayed in return. It seems as if even the Earth has grown wary of begging for the support and care of man. After holding out for decades before falling ill from invasive toxic processes like greenhouse gas emissions, it is almost as if you can see the Earth's exhaustion with each laborious earthly breath. As humans continue to take, the Earth continued to give, allowing herself to be taken advantage of, running feverish for years on end, and seeing her children die before her. And still, before the Anthropocene, the Earth had never lost what we have managed to take from her. And still, each day, the Earth gave to us with overwhelming abundance. Until we finally started to take things that weren't even the Earth's to give. Like the Arctic that once appeared to be a permanent groundskeeper in the northern hemisphere, helping the Earth with safe storage of her historical belongings, keeping a freshwater reserve, helping to balance toxic gases and elements like mercury at a stable and non-reactive location. It seemed the Arctic and the Earth had long been very good friends. But that was before the Earth met the human condition. With so many positive climate feedbacks happening at one time, it is very difficult to say what types of challenges lie ahead. But one thing is certain, and that is that we are certainly unprepared. One of the most singularly profound events that mirror how unprepared humans are to be catapulted into this potentially apocalyptic climate future was seen in Norway in 2016. In 2008, the Svalbard Seed Vault was opened in Norway, in the Arctic archipelago of Svalbard, on the island of Spitsbergen. Built to preserve genetic diversity and accessibility of food crops in the event of a global catastrophe, the vault is home to some 4.5 million seed samples. After just 8 short years, a record-breaking Arctic summer in 2016 changed everything. The summer began after a record-breaking low in both snow accumulation and Arctic sea ice. By August, the average temperature in the Arctic was 9 degrees Fahrenheit. In less than 10 years, the amount of climate change that was seen in the Arctic shocked climatologists to geneticists to scientists and to civil engineers. Not only was everyone on the project completely unprepared, but to add insult to injury, there was not even a single projection that indicated that scientists and engineers thought that it would reach this level in the world's history. The vault was built under almost 4,000 years of Arctic permafrost. The vault was surrounded by hundreds of feet of frozen Arctic permafrost in every direction. But despite every effort made, in 2016, the thawing Arctic permafrost flooded the entire vault. By a stroke of luck, the seed stores were not completely destroyed. But it is incredibly disheartening to think that the people we are supposed to be able to turn to for help cannot even help themselves. There is no history book or wives' tale or fabled religion in the entire world that can save us from this future we have created. As positive feedback loops continue to magnify the impact of climate feedbacks and climate forcing, we cannot even get an idea of when this shocking transition might plateau. A complete lack of global synchronicity has left everybody in the dark. To what degree climate feedback will be amplified too, we do know that climate feedbacks in general are going to be more intense going forward. One reason for this is that water vapor evaporating takes only 1/5 of the energy to turn into a gaseous form than it does to turn into its frozen form. Increased water vapor will increase flooding, rainstorms, storm intensity, storm surges, things like typhoons, cyclones, and other types of water-related storms and tropical surges of energy. Precipitation will also increase as a factor, but so will drought. Flooding will see an all-time high, but the land will also desiccate in between flooding periods. Increased radiative forcing will raise global temperatures as well as intensify weather patterns as well. It is not because the sun has gotten hotter or anything like that. It is because of the heat absorption done by greenhouse gases and the dark surface change in the Earth's surface without ice. Consistent weather events will become more spread apart, but sporadic and intense weather events will become more frequent. Radiative forcing will result in increased oceanic surface temperatures and increased ocean stratification. Any one of the feedbacks that I just mentioned would make it very difficult for the Arctic to survive, but when you combine the impact of all of them together, almost none of us stand a chance. Furthermore, the resilience of the Earth will be greatly negatively impacted by all of the different pressures like drought and flooding when it comes to the reproduction of agricultural development after massive climate events. The situation has gotten so difficult, it is difficult sometimes to know why we are having this conversation any longer. And it's in moments like these that I remember that we still actually have it quite well here, and that there are many places like the Philippines where people are struggling with famine and economic devastation and can't recover because of climate events happening in such rapid succession. Fully understanding why this is happening is a crucial part to understanding how we can mitigate the effects going forward. It is becoming more and more difficult to know exactly just what to do. However, that cannot be the excuse that we use so that we do not have to strike out into the world to help others. The time has come to take stock and appreciate all that we have in our lives and realize that this is probably going to be the fight of our lives. And even if we only recover our humanity through the solidarity that comes from fighting against mutually assured destruction, we maybe someday will stumble into a future together where we get a chance to believe again that tomorrow might just be a little less terrifying than today was, because today was just a little bit less terrifying than yesterday. Though we don't know to what degree everything will be amplified going forward with the climate, we do know that everything will be more severe. When climate